A 15-meter long beam ABCD is simply supported at its ends A and D. Point loads of 50 kilonewton is applied on the beam at B and C, which are 5 meter and 10 meter away from its support A. Draw the BMD and SFD for the arrangement. I have drawn a sketch. In most of your numericals, they give a drawing they supply a drawing along with the numerical if it is quite complex. If it is something very simple like this, then they will give a diagram. They will give the numerical in words like this. Okay, so you have to draw the diagram based on this statement. Now it says it's a 15-meter long beam ABCD. So I have drawn a straight line which is representing my beam ABCD, and it is simply supported at A and D. So I have shown two supports at A and D, and it is carrying a point load of 50 kilonewton at B and C, which are 5 meter and 10 meter away from support A. This is support A. 5 meter away from A is B, where I am applying 50 kilonewton, and 5 plus 5, 10 meter away from A is C, where again I am applying another 50 kilonewton. Okay, you have to draw the BMD SFD for this arrangement. Now after this, the first step that we have to do is to find the support reaction at A and D. Now in order to find the support reaction, we need to do two things. First is summation of all the forces is equal to 0, and summation of all the moments should be equal to 0. This two condition is the requirement for the beam to be in equilibrium, otherwise this will not be in equilibrium, correct? So now I will put the first condition, that is summation of all the forces is equal to 0. Before that, I will just show the reactions. So reactions we generally name as R suffix the point name, right? Now this is RA and RB, right? So I'm just putting it here, RA, and this is RB. Now if it is quite complex, then you need to do this step. With step, summation of all the forces equal to 0 and moments is equal to 0. Now if you observe this diagram, this is symmetric, right? If you draw a line at the center, it is a mirror image, right? The load is equal, the distance are also equal from the support. So in this case, I can easily calculate the reactions. How to calculate the reactions easily? You just add the total load on the beam and divide it by the number of supports. That will give you the reaction at each end. Now instead of two load, if there were to be a single load, then it would be W by 2. Now it is W1 and W2, so I can just add W1 plus W2 divided by 2. That will be the reaction at A and reaction at B. If you want, you can do the same method also, but since this is simple, we will do it like this. So the reactions will be 50 plus 50, that is 100, by 2. So that will be 50 kilonewton at RA and 50 kilonewton at RB. Okay, so I'll just write that, or I can just copy this. 50 kilonewton, and RB is also equal to 50 kilonewton. Okay, now I have this, and the load here is also 50 kilonewton. This is given already. Now I can draw the shear force diagram. So for drawing the shear force diagram, what I'll do is, first I'll draw a reference line like this. So like I said yesterday, whenever you're drawing the shear force and bending moment diagrams, you start from a fresh page from the top, because you will have 3-4 diagrams which will come in the one below the other, and these lines will help you draw it properly. Now, this is a very simple method what I'm explaining you for drawing the shear force diagram. So how to draw the shear force diagram? Now, start from extreme left end always, whether it is cantilever beam, overhanging beam, simply supported beam, whatever the type of beam it is, you always start from the left end of the beam. Now here I have a force 50 kilonewton, which is the reaction, which is upward direction. So I will start from here. I will take, let us say, green color. So I will draw a straight line which is 50 kilonewton. This is representing 50 kilonewton, whatever scale it can be, right? There is no need for exactly drawing to the scale. If you do it, it is well and good. Approximately, it should be proportionate. That's all. Okay. Now, between A and B, there are no loads, right? There are no load between A and B. So I will draw a horizontal line from A till B. Okay. Now at B, I have 50 kilonewton load which is acting in downward direction. So at B, what I will do, I will draw another line of 50 kilonewton up here. So 50 kilonewton, it came down. Okay. Now from B to C, I do not have any load. So again, I will draw a horizontal line like this. At C, I have another 50 kilonewton load. So I will draw another line like this. Then I have no load between C and D again. So I will draw another horizontal line like this. And I have reached D, where I have reaction equal to 50 kilonewton. So I will draw another line like this. Okay, so this represents the um, shear force diagram. I'll pause the video here. Okay. Now let us proceed. I'll just name this as SFD, right? Shear force diagram. Now, after drawing the shear force diagram, see actually in your if you see the book, they have given a lot of confusing methods for calculating the shear force. This is the easiest method which we were taught when we were in college, right? I did not find any other method which is easier than this. Now, you just have to mention the shear force values at all these points. Now, for example, at point A, you have to write shear force at point A is 50 kilonewton, and at point B it is decreasing from 50 kilonewton to 0. Between B and C there is no shear force. Shear force is equal to 0. And at C there is a shear force which is acting downwards of 50 kilonewton magnitude. And at D again there is a shear force of 50 kilonewton. You have to just mention that in your answers. Okay. Now the next part is to calculate and draw the bending moment or bending moment diagram. So I need more space here. So I'm just extending these lines. Okay. Now again, what we have to do is I'll first draw a horizontal line which is representing my beam. All right. Now I have to calculate bending moment at all the points. Now I have 4 points on this beam: A, B, C, and D. Now always the bending moment at the ends will be 0. Free end whenever you have, the bending moment at this point will be 0. So directly I can write Bm at A is equal to 0, free end. Okay, Bm at D equal to 0. Again this is free end, or it is the support, right? The next point is, let us start from this side, point B. So Bm at B is equal to. Now, how to calculate the bending moment at B? So you can take moment either from the left side or from the right side. But what I usually do is I see the forces where I have less number of force, I take on that side. This is the convention what I follow. This is the method what I follow. You are free to do it either ways. You can take the moment from left side or from right side. Now I need to use some sign convention. So the sign convention what I generally teach my students is like this. So what you can do, you put a plus mark like this. Okay, and then I write here, this is left side and this is right side. This is CCW, CW. So left side counterclockwise you can take it positive, and right side counterclockwise you can take negative. Left side clockwise you can take negative, and the other one will be positive. So diagonally it should be same sign. So if you put plus here, then this should be plus, and this will be minus, and this will be minus. So you can use any sign convention of your choice, but usually in the BMD and SFD, when the beam is loaded, this beam tends to bend like this, right? So this is called sagging bending moment, right? Because if you see, there is support here, there is load applied on this beam, because of which the beam will bend like this. This is called sagging. Now there can be a reverse condition. If the load is upwards applied from here and the reaction is downwards on the end, then the beam would be bent like this, right? So this is called hogging bending moment. So sagging bending moment is taken as positive. This is taken as positive, and hogging bending moment is taken as negative. This is another sign convention. Okay. Now I will show you how I do it. I'll just delete these things. So bending moment at B. Now I need to find the bending moment at this point. So I will take this force. This is now this force is making this rotate in clockwise direction, and it is on the left side. So that should have been positive. I'll just swap these two. Okay, so left side clockwise, so that will be positive. So I'll just put this here, and the value will be equal to 50 kilonewton into 5 meters, right? So this will be equal to, let me open the calculator, 50 into 5 is 250, 250 kilonewton meter. You need to be careful with the units. So 50 kilonewton into 5 meter, that will be 250, 250 kilonewton meter bending moment at point B. Now I need to find the bending moment at C. So Bm at C is equal to, now you can either take this side or this side, right? It will be same. So since on the right side I have only one force, so I will take this. So this is upward force, and it is making counterclockwise rotation on the right side. So right side counterclockwise, this is positive. So the value is again 50 kilonewton into 5 meter. So it will be same as this, right? So bending moment at C is also 250 kilonewton meter. Now I have bending moment at all the 4 points. I can draw the bending moment diagram. So for drawing the bending moment diagram, I'll first start from point A. At point A, the bending moment is 0, so it will be here. And at point B, it is 250 kilonewton meter. So from 0 to 250 kilonewton meter, it varies like this, right? It is increasing from 0 to 250 kilonewton meter. From B to C there are no points, so it will remain constant here. It will be constant like this. At C it is again 250 kilonewton meter, so this is 250 kilonewton meter bending moment. At D it is again 0, so it will decrease from 250 to 0 like this. Alright, so you just have to write the values at all these points. Now here it is 50.
Hello, so
Yes.
sir, C to D, can you explain it once, sir? Bend this.
See, at D, at C it is 50 kilonewton, 250 kilonewton meter. Between B and C there is no load, so it will remain constant. At D it is 0, right? So I am here
Yes.
at 250, so I just have to join this point with 0.
Okay, sir.
Okay,
Thank you, sir.
have to join it like
Thank you.
yes, right? Again here it is 50 kilonewton. Here it is 0. Here also it is 0. Here it is 50 kilonewton. Here also it is 50 kilonewton. And again it becomes 0. And here it is 0. This is 0. And this is 250 kilonewton meter. And this is also 250 kilonewton meter, right? This is positive, this is positive, and this is negative. Shear force, whatever section you get above the line will be positive, below the line will be negative. Bending moment, above the line is positive, below the line will be negative, right? So this is the solution to this numerical.